So again, good afternoon all. My name is Ashutosh Acharya. I'm the second year student of Mechanical Engineering Department of the Government College of Engineering. And again, I hope my presentation is visible to you all. Topic of my presentation is telescope. So why do we require telescope? Telescope basically. As you all might be knowing that telescopes are basically the devices which we are using to view distant objects, right? Basically, a telescope collects light and channels it into our eyes. And again, a device we have to a device used to view distant objects. Let me give you an example. Before you lies two images. The one on the right hand side is taken from a simple phone camera, whereas the one on the left hand side is taken from a telescope. As you yourself can see the difference between the two images, right? The image which is taken from telescopes, we can clearly define that which one is Saturn and which one is Jupiter and which one is Saturn here. And along with that image, we are able to see all the three moons of the Jupiter, right? Whereas the right image is of the same two planets, the Jupiter and the Saturn, but we are really not able to differentiate which one of them is Jupiter and which one of them is Saturn. So, why can't we see objects clearly which are far away from us? Because we are not able to gather as much as light possible from our eyes, right? Because our eyes are a little bit smaller. So let me talk about the basic components of telescope, right? Basically, in a telescope is basically made up of two components, that is an objective lens in case of refractor telescope and an eyepiece. Basic purpose of objective lens in short is to gather as much as light possible coming from the object which we are viewing. Whereas the main objective of the eyepiece is to view the object. Like eyepiece is giving us a clear view of the object. So let's talk about lenses first. So as you can see through the image, as you might have studied in your 12th standard as well, the light coming from distant objects which are at a very far away distance gets using a convex lens. They all get converged at a focus, right? And again, this is the very simple phenomenon which we have studied in our 12th as well. Our eye is also a kind of convex lens, and the light rays which are getting reflected from the object and getting refracted through our eye lenses are getting converged at a point in our retina. As you can see in the right hand side image as well, considering the example of dog, I'm just explaining how lenses are, right? Considering the example of dog, if the light rays getting reflected, light rays are falling on dog and they are getting reflected to the lens. They are being refracted and we are getting an inverted real image. Same happens with our eye. We are viewing an object, that is the dog. Our light rays are coming from dog and we are able to view the dog. An inverted real image is formed on the retina of our eye. And our brain interprets it as a like what we are seeing right now. So the objective of a telescope is used to collect the light in a greater format. The light rays which are falling on objective of this objective lens, they are getting converged at a focal plane. A focal plane is a plane where which is kept at focus, right? And from this focus, the light rays are further getting diverged into the eyepiece, and through this eyepiece, we are able to view the object. So there is a definite focus of focal length of eyepiece and the objective lens as well. So this is about telescope. Now let me explain to you in very simple words, the simple language, how a simple telescope is working. Consider an object P and Q which is situated at a distance. The light rays are coming from this objective P and Q, and they are getting refracted through an objective lens. So this is the objective lens. Alpha is the angle subtended at focus, we say. So this light rays coming from PQ are getting converged and they are forming a real image. they're forming a real and inverted image at the focus, right? And through this eyepiece, we are able to view this image, right? So again, the image is inverted, and if we are viewing the image through eyepiece, right? So the image which we are viewing through eyepiece will be an enlarged image. The purpose of eyepiece is to magnify the image which is formed right here. I hope it's clear to you guys. The diagram is clear to you, and like a very simple working of a telescope. So again, the purpose of eyepiece is to produce and allow you to change the telescope's magnification. The purpose of eyepiece is to produce a sharper image and provide a comfortable eye relief, the distance between your eye and the eyepiece when the image is focused, and to determine the telescope field of view. Right. So talk about filters a little bit. So basically, filters are the they filters light, right? Okay, so filters are a piece of glass or plastic, right? They are telescope accessories which are used to which are either applied on the eyepiece or they are placed at the focal plane if we are using if we are doing astrophotography through CCD. So basically, filters allow a specific band length of light, a specific wavelength of light to pass through them, right? There are various types of filters like red filter, light blue filter, and so on, and light pollution filters as well. So let's talk about two main types of optical telescopes. My entire presentation is about optical telescope, right? So basically, there are two types of optical telescopes. There are refractor telescopes, which use glass lenses, and another type is reflector telescope, which uses mirror instead of. So both accomplish the same thing, but in different ways. So let's talk about refractor telescopes first. So basically, refractor telescopes, which most of us are familiar with, they have falling parts, a long tube made of metal, plastic, or wood, a glass combination lens at the front end objective, and a second glass combination lens, this eyepiece. So basically, in a refractor telescope, we have the observer, we are with a distant object. Light, the object which we are with, light is at objects, and it is again getting converged at the focal plane, and from this eyepiece, we are able to view the magnified image of the object which we are viewing, right? This is the very simplest explanation of how a refractor telescope is working. So what are the limitations of refractor telescope? Like the need of reflector telescope if we are having refractor telescopes? Here are the three limitations. That is the aperture. If we consider the case of refractor telescopes, lenses, and the main thing in lenses is that lenses are difficult to manufacture. That's the limitation, right? And again, manufacturing of large lenses is actually difficult as well. That's one reason why refractor telescopes are not used that frequently. Again, chromatic aberration. So chromatic aberration is a phenomenon where, as we all know, the different wavelengths of light refract differently. That's the reason why chromatic aberration is happening. And spherical aberration is happening because all the light rays are not parallel to our principal axis. Right? All the light rays coming from the object is not parallel to the principal axis. That's the reason why spherical aberration occurs. We are getting blurred images sometimes while observing. So that can be, all these two things can be corrected by using, all these two limitations can be overcome by using various combination of lenses, which we won't be talking in detail about right now due to time constraint as well. So let me give you a short overview about reflecting telescope, like how reflecting telescopes work. Reflecting telescopes focus is light by bending them with mirrors, right? The light is coming from objective, and here we have placed our mirror, which will be reflecting light on the secondary mirror, and from the eyepiece we are able to view the image of the object which is formed at secondary mirror. So one advantage of reflecting telescope is that we won't be having a chromatic aberration, right? Because all the light are reflected in this reflecting telescope. So that's a very short overview about reflecting telescopes. Not everything is visible, right? There is a whole lot of spectrum of light which we are electromagnetic radiation spectrum which we are not able to view, right? We are able to view only visible spectrum. There lies gamma ray spectrum, X-ray spectrum, ultraviolet spectrum, infrared rays, radar, and so on. So uh, many modern day telescopes do not use visible light to collect images. Radio telescopes, X-ray telescopes, and infrared telescopes have become a staple of modern day astronomy, producing some amazing images. So optical ray telescopes, radio telescopes, X-ray telescopes, and gamma ray telescopes are other types of telescopes which are used in modern day astronomical researches. So that's all about my presentation. Thank you very much. I hope you guys are clear with this. Uh, my voice was breaking, I guess.